In Chapter 10, just as in Chapter 9, one of the difficulties can be to figure out whether you're supposed to be doing a Chapter 10 problem versus, say, a Chapter 9 problem with sample size or confidence intervals. And then if you know it's Chapter 10, how do you know which one to do? Because we have two different tests available to us. So the first thing to look at is the question words. So for a hypothesis test, it becomes a little bit obvious what you're supposed to do because it'll have the words like conduct a hypothesis test or prove this or test this result, that kind of thing, or test this claim. If they ask you to test a claim, right, then that would be a hypothesis test, as opposed to construct a confidence interval, which is confidence interval stuff, or how many, what sample size. That would be a sample size question. All right, so it'll say hypothesis test or test somewhere in the problem. Now, if it does that, then which one do you choose? Well, you have two available to you, right? So if we look at our exam notes packet for a second, right here I have the electronic version, although I will probably pull out the paper version as well. It says to hypothesis test for a single proportion. We learned about that in section 10.2, right? And then on the next page, it has a hypothesis test for a single mean, which we learned about in section 10.3. So those are the two that we're working with just in chapter 10. There are more. There are actually lots more. We will learn a few more in chapter 11. If you kept going in statistics, you would learn many more. There are so many different types of tests. Okay, so let's look at this. So we have a hypothesis test for a mean, and we have a hypothesis test for a proportion. Okay, so let's look at our blanks right here. So we can fill these out a couple ways. It's kind of up to us what we want to do. So for these ones, we want proportion. So if you're testing proportion, that will be the one that's on page, well, it's the one from section 10.2, the one for a proportion, as opposed to the one for a mean, which I will do in a different color, just to try to keep them straight. All right, so now how are you going to know it's a proportion one? Well, for one thing, you're going to look for proportions in the problem, right? If the problem is talking about proportions, percents, if it talks about a survey, also known as a poll, right? We polled, 300 people and we found this. That is a proportion question, right? As opposed to a mean, which, you can look for the mean. You can look for average. If they're talking about average, that's generally a mean one. If the standard deviation is somewhere in the problem, and if you have a data table, if you see a data table sitting in the problem, that is going to be a mean question. We do not do proportion questions that way, right? We do mean questions that way. All right, now we already saw this, but I'll say this was section 10.2. This was section 10.3, right? So your hypotheses, and I'll just give you the null hypothesis because, quite frankly, that's what you're going to be able to tell. The alternative is going to be based on what the problem is, right? So if you look at your proportion ones, every single one of them is H naught P equals P0, where P0 is some particular value, right? So it'll be P equals 10%, or P equals 0.10, or P equals, 0.72. It'll be whatever. Okay, so that's what you'll put right there. So these ones will be H naught P equals P0, P0 being some number. All right, whereas these ones will be H naught always mu equals mu0, right? Mu is equal to a number, and I can show you that on the next page, right here in your exam notes packet. Right, so every one of them has a null hypothesis that is mu equal to mu0, where mu0 is some number, like 522, or something like that. So you're going to have to look at the problem and figure out, are they talking about proportions? Are they talking about percentages? Or are they talking about means? Because it very much affects which one you're doing. All right, now there are some other consequences of this. First of all, the normal qualities. So normal is a condition that we need in order to be able to run the test. So if I go back to the proportion ones right here, normal is that n times p0 times q0 has to be greater than or equal to 10. 0, of course, P0 being the value that is assumed of the parameter in the null hypothesis. Remember, P is the population parameter. P is the population proportion, right? Parameter being a population value that is unknown. So we are assuming the population parameter is this P0 value. So that's that same P0 right there. And then Q0 would be its complement, 1 minus P0. All right, so let me go fill that in. If I could grab the camera, there it is. Okay, so for normal, we need n times P0 times Q0 to be greater than or equal to 10. Lovely. Now, for the mean one, it's actually more involved in a way, because there's actually a few ways that it can happen. So for a proportion one, there's only one way. It has to be that n times P0 times Q0 is greater than 10. But for the mean ones, and I didn't even mention it in here, but I could just give it to you. I could just say in the instructions somewhere, it's normal, right? So if I state it, right, if it's given, then that's fine. I could give you a graph, right? Usually a normal probability plot where you're looking to see if the points are linear. Or you could have your sample size be greater than 30, right? Those are our 3 rules of thumb. So I could give it to you. So it could be given, or it could be a graph, or, because I'm not going to do all of these, right? It's going to be one or the other, n greater than or equal to 30. And we kind of do the graph thing and the n greater than 30 thing pretty much equally. We might occasionally get a given one, but for the most part, it's going to be a graph or n bigger than or equal to 30. All right, now what about technology? Well, it depends. So if I go back here, and I put it right here at the top, so you can see these now in this particular semester that I'm making this video, this is page 276 right here. And the next page is 277. So if you want, you can say that to yourself. In StatCrunch, it's the stat proportion one sample with summary, just like it was for a confidence interval. But with the calculator, it's one prop z test. So either one you want. If you're using a TI-84, write that. If you're using StatCrunch, then use that. I'll do StatCrunch first because I imagine most of you are using StatCrunch. So it's stat, proportion stat. I'm just going to write prop stat to fit this in. Then one sample, and then with summary. There you have it. All right, so that's StatCrunch. Now, if you are using a TI-84, instead of writing that, and I'll just kind of put it up here. So the TI-84, don't write this if you're not using a TI-84. There's no point. But it'd be one prop. Prop stands for proportion, z test, because of course z is the critical value as well as the test statistic, right? Your test statistic is z0, which actually I guess I shouldn't mention that. Let me kind of add a couple lines down here. So I'm going to add what page it is right here. So again, this is going to change for every semester, so just kind of keep that in mind. So if you're watching this in a later semester, this might not be where you expect it to be. All right, so for me, it's on page 276, right here. So for me and my course pack, it's page 276 for this one. But again, put whatever semester or whatever page it is on the semester that you're watching this. So 276. And the test statistic, I just kind of want to mention that. It's this thing in the middle. That's the test statistic. It's Z0. These are Z tests that we're running here, right? So Z0, which is either one of those formulas. I'm not actually going to bother writing the formula. That's what this page is for. You go to page 276 and you'll figure it out. But we can mention to ourselves that it's a Z0, that we're doing a Z test here. It doesn't hurt to write that down. Oh, I should have underlined that too. Okay, so now what about this one? Okay, well, the tech for this one's a little different, so we're going to go to the T-stat area. And again, this is on page 274, so let me give it a little page thing. I should have added that in. Sorry about that. And for me, this semester that I'm making this, it's 277. If it's on a different page, then by all means, put whatever page it's on for you. So I'll show you it too. It's right here. Hypothesis test for a single mean, section 10.3. And for me, it's on page 277, but it might be different for you. And you can see that up here is the tech. So it tells you stat, t-stat, one sample. You're going to have to choose either with data or with summary, depending on what you're doing. If you're in a calculator, it's just t-test, which I know sounds easier, but actually the calculator is more difficult, but there you have it. And you can see down here, the test statistic is a T0 because we're running a t-test. So let me kind of add those lines in right here. So test statistic. And we're doing T0. Oh, that was all in pink. 1 second. I forgot I was trying to color coordinate this, so I switched them to pink. So 277 and T0. Now in tech, I'm going to write this down. We go to stat, of course. We go to t-stat. We had one sample. If you're wondering about the two sample, that's what chapter 11 is for. And then you're going to either choose with data or with summary. It depends on what you're doing. If they give you a data table, right, a big old table of data that you have typed into StatCrunch, then you'll use with data. If they give you a paragraph with all sorts of information in it, but no data table, then you're going to use with summary. So it just depends. If you're on a TID4, and again, don't bother writing this if you don't have a TID4, you're doing t-test. Oop, if I could spell it right. Here we go. T-test. There you go. Oh, sorry about that glare. Let's see if I can get that better. All right. What are some other words that often cue hypothesis tests or an hypothesis test? So one, if you see the word significance floating around, is this significant, right? Is there a test of significance? What's the level of significance? That kind of thing, right? So level of significance is also kind of a big one. I'll just put level of right above. If you see that floating around in there, that'll be. And then can you conclude that? Oh, that's another one they like to give. Can you conclude that the mean is blah, 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 right? That. Can you conclude that, yada, yada. And so if you see that, right, that conclusion comes from an hypothesis test. So that's kind of implying that. All right, next. All right, so these are some things to remember that we learned about in 10.1 and we never want to forget, because this is true just for all hypothesis tests in general. First of all, there's a relationship between type 1 and type 2 error. Okay, so the probability of a type 1 error, let me put it down here, is alpha. Here, I'm going to switch to a different color real quick. So this is alpha, this is beta. This one's called significance level, right? It's the probability of a false positive in medical screening tests. Right? It could be other types of screening tests as well, but it tends to be that way, right? For medical in particular. And then this is the probability of a false negative in medical screening tests, or just screening tests in general. Oops, I forgot the word tests here. All right, I'll just throw that in there. Okay, so what's the relationship between the two? Well, the answer is that they are very strongly related to each other. Alpha and beta have an inverse relationship. So if alpha goes up, beta goes down, and vice versa. Now, what do I mean by vice versa? I mean that, I'll just put it over here, if alpha goes down, then beta goes up. It's like they're on a teeter-totter together, right? So if one of them lowers, the other one will raise. Okay, so you have to keep that relationship in mind, because that's going to be very important to you. If you want a low chance of false positives and you make alpha go really, really low, then you'll inherently drive up your false negatives, and vice versa, right? So that's what the vice versa means, right? So it's going to work either way. All right, next, statistical significance and practical significance are not the same thing, and everybody always gets them confused. So statistical significance means, did you get to reject H naught? That is what is statistically significant to us. We want to reject H naught. If we can do it, because our p-value is less than alpha, alpha being our level of significance, significance level, aka level of significance, right there, alpha, then we get to reject H naught, yay, right? But that doesn't necessarily mean practical significance. Practical significance is a judgment call. That you have to make based on context. Now, to be fair, you can't be practically significant in general if you're not statistically significant. But statistical significance alone is not enough to make practical significance. Right? So to do that, you'd have to compare in your head X bar, your sample mean. Oh, I should do this in order. So I'll do p hat to p0, right? If you're doing a section 10.2 test, or if you're doing a proportion test, or if you're doing a mean test, it'd be X bar to mu 0, right? The value that was assumed to be true in your null hypothesis. So you'd have to compare those two and say, okay, it might not have been statistically significant, but I think it's practically significant, or it might have been statistically significant, but I don't think it's got practical significance. It wasn't a big enough difference. So you'd have to compare the two. Right? In general, practical significance requires statistically significant, but it's not enough on its own in order to prove it has practical significance. All right. Last but not least, never forget what a p-value is. So important. So p-value is the probability of a fluke. That thing we talked about way back in chapter 8. So it's the probability that, and just to make this easier for you guys to read, I'll switch colors. So it's the probability that your sample statistic, which were these two values, right? So p hat or X bar, those are the only sample statistics that we know at this point, are by random chance if H naught, ooh, sorry, I ran out of space, if H naught was true. Oh, here, I'll put it over here. There we go, I'll just kind of separate that. Okay. So it's the chance of just randomly getting what you got by accident if H naught was in fact true. That's what a p-value is. It's saying, hey, assume H naught is true. What's the chance of getting what we got that was really far away from that? Could it have just happened by chance? Sure, but the probability of that is what a p-value is. P-value is the probability. That's what the p parentheses stands for. It's the probability of getting that sample statistic by random chance if H naught was true. Sorry, close that parentheses. All right. What does that mean? That means that if the p-value is low, and I don't know why I didn't capitalize these, sorry. If the p-value is low, then we reject the null, right? So p-value is low, we reject H naught. And we always want our p-values to be low. The lower, the better, right? Lower is better. You want to reject. Your goal here is to prove statistical significance. Statistical significance happens when you get to reject H naught. It's right here, right? You get to reject H naught if your p-value is less than alpha. So if your p-value is a lower number, you're going to get to reject more often. And that's what you want. You want your p-value to be low. The lower, the better.